So for this one, we again go kind of straight to the instructional part for 3. You can read over it, but as we explain this one we're using a level of significance of 10%, and we're asked to do a one-tailed hypothesis test. Now, this really doesn't tell us enough because we don't know if it's a left tail or a right tail. So we have to go ahead and read what the company's claim is. Company General Electric claims that a certain brand of its flashlight batteries lasts, on average, 300 hours of flashlight use. 100 hours of flashlight use. You suspect the population of batteries average fewer than 300 hours. So that's going to tell you that this is going to be a left-hand tail. So you kind of believe it's going to be less than 300. So we set up our null hypothesis with the the mean equal to 300 hours, or greater than or equal. But this is how we set it up with our tools, our statistics tools. But it's going to make the alternative hypothesis that the mean is less than 300. Okay, so this is actually, yeah, the mean is greater than or equal to. Okay, so we'll get that set up, and we'll get our standard normal set up just for our own understanding. Again, the calculator at the end will produce this graph for you, but if we kind of go into it with the correct understanding, it's oftentimes helpful. So one-tailed, we know it's going to be a left-tailed test. So that is like this one here with the rejection region down to the left. And we're doing a 10%, a left-tailed test. So we're looking at a negative 1.28 as our z-score that we will highlight here. So -1 is here. Here's -2. There's about -1.5, right? And so 1.28, there's close to 1.3. It's about here. We don't have to be completely exact or anything, but we just come in here and let me clear this one out. It's kind of just in the way. We'll label this our 1.28, actually -1.28, and this is our rejection region. We're going to do take that sample, have the calculator generate a test statistic, and see if it's in this region. If it is, we will reject. If it's not in that region, if it's in the usual region, then we fail to reject. Let's see if we're doing a T or a Z. And so we read so far to the 300 hours, a random sample of 49 batteries. So it's large enough sample size. We could probably do either one and be okay, right? But this is saying that the sample has a mean of 290, and they are giving us that the sample standard deviation is 270. Now, if you want to test me out, I'm going to go with the t-test. So I'm going to say this is a t-critical, which again would, if the sample was less than 30, we'd actually have to look that up in a t-table. But what allows us is we're over 30, and the tables are the same after 30. So since the tables are the same, we're going to end up with the same values. Okay, not much difference there. Let's see, what do we do next? I think we're all in good shape to go ahead and hit into B. I'm going to change color to the nice golden one. We're going to calculate that test statistic. So we come to inferences, and we're doing tests. We're going to do, this is a mean. It's not a proportion yet. It's not a percent. And we're going to do a t-test. We have 300 hours as our null hypothesis, with the alternate hypothesis being less than, the mean is less than 300, so that we get a left-tailed test. We're going to input our statistics. We've got a sample of 290, which is less, but we're going to see if it's statistically significant, standard deviation of 70, and a sample size of 49. We're doing a 10% test, so that's a 0.1. Going to go next, and our t-statistic is -1, which is right here. And notice we are not in the rejection region. So this was our test, our t-test statistic. Well, I'll just call it the t-statistic, test statistic, t-stat, was equal to -1. So we see it's not there. And then what you're going to see in the calculator will shade back this way, giving us a p-value of 16%. So if we were to shade all the way back, I'm just going to do this part, but so the gray area is 10%. The golden area is going to be 16%. To around that 4 decimal places, you know. We'll switch back here to gray. The alpha area is 10%, 0.10. And so we see our p-value is bigger than the alpha, so we fail to reject. P is greater than alpha, fail to reject. Okay, now let's go ahead and write this one up and see what we can say about these flashlight batteries. Now remember, since we failed to reject, we do not have evidence of what we were seeking. We cannot say, so let's see, I guess we go through all of this, but I always like to kind of write up our statement first. So I'm down in here. Let's go with a blue color. So we fail to reject. What are we failing to reject? H naught. Let's just put it that way. There is not, I'm going to put that in, screaming, not enough. There is some evidence, but not enough evidence to believe or say, or, yeah, I'm just going to put to believe that the mean flashlight battery lasts less than 300 hours. Just abbreviated hours like that. Okay, something like that. So that this brings in the null hypothesis. We can't say, or sorry, the alternate hypothesis. We can't say anything about it. So is your test conclusion, if it's an error, we don't know it but if it were an error, what kind of an error would we have? Again, we can come back to this chart here. And this is, since we did not reject. We failed to reject. This is what we did. The only type of error that is associated with this is a type 2 error. It means maybe the null was false. Maybe it should have got rejected, but we didn't. So that's a type 2 error. It's a lesser of an error because what's going to happen is, well, we don't really have evidence to make any kind of decision, so we're just going to do what we do anyway, right? We're not doing something based on the falseness, but it would be a type 2. So be able to answer those kind of things. And again, we just come to our chart. If we would have rejected the null, then we could have potentially had a type 1. But the type of error is dependent upon the decision. Did we reject or not reject? If we did not reject, then it could potentially be a type 2 error. If you did not reject the null hypothesis, that's what we did. What are you concluding about the difference between the sample mean battery lifespan and the battery's claim? This is what we mean. That's our statement. We failed to reject. there is not enough evidence to believe anything. So we can't believe that it's less than. We really, there, anyway, we can't believe it's greater than. We can't believe anything that we fail to reject. So this sample does not provide enough evidence to do anything, something like that. So that's number 3.